Hello, my name is Jayson Lusk. I am the incoming president of the AAEA, and in the last couple of years, we've introduced a new type of session to the meetings, a lightning session, in which we have several papers that are relatively short. So the presenters have about 7 minutes for their presentation, and then 2 minutes of questions following that. So today, to give you an example of how these lightning presentations will go, we have Josh Maples, who is a PhD candidate at Oklahoma State University. Josh?
I'm Josh Maples from Oklahoma State University. Today I'm going to be giving you an example lightning session presentation for the AAEA meetings. This is a paper I've been working on with Jayson Lusk and Derrell from Oklahoma State. When bigger isn't better, stake size and consumer preferences. The average cattle slaughter weight has increased by over 300 pounds over the past 4 decades, up from about a little over 1,000 pounds in 1977 to 1,364 pounds in 2015. Much of this increase has occurred in the last 10 years. We've seen over a 100-pound increase in the average cattle slaughter weight since 2005. Now, there are many reasons for this increase. However, today I want to talk to you about some of the impacts of this, and not necessarily the causes. One direct impact is an increase in the size of some cuts from the carcass. Ground beef may not be directly impacted because that cut's going to look the same regardless of the size of the animal. However, there are cuts such as steaks that are proportional to the size of the muscles from which they are cut. So as the animal gets bigger and these muscles get bigger, the steaks are also larger. And we can see this from the average ribeye area increase over the past few decades. So using data from the National Beef Quality Audits, we were able to estimate what the average ribeye would have been for their sample in 1977, around 11 square inches, or to 2015, over 15 square inches. So we've seen a 4 square inch increase in the average ribeye area size. And our main question is, what impact does this increase in steak size have on consumers? Larger area steak means that consumers either have to accept a more total weight, or they must accept some sort of adjustments to the dimension of the steak. And most consumers don't want steaks that have been cut in half, so really this adjustment usually becomes cutting the steaks thinner. A good example would be going to a restaurant and purchasing a 12-ounce steak. A few decades ago, this steak might have been smaller and therefore thicker to meet the 12-ounce requirement. However, today, when the area of ribeyes are larger, that steak is more likely to be larger area and therefore cut thinner to meet the same target weight. And the only alternative to this is heavier and therefore more expensive steaks. And by more expensive, I mean just because most steaks are priced by the pound. And so if the area gets bigger and you still want to keep thickness the same, the package is going to weigh more and therefore be more expensive. So our objectives and our methods that we're going to use to look at this are, we want to estimate consumer preferences for steak dimensions, and we specifically look at sirloins and ribeyes. We do an online national level survey, have over 1,000 respondents, broadly representative of the U.S. population. And then we're going to estimate a latent class model and calculate willingness to pay for particular attributes. Then we're also going to look at the change that may have occurred over the last few decades due to this shift to potentially larger and thinner steaks. I want to touch on some of our margin utility results first. So we identify 5 significant latent classes, but there's about a 75% chance that respondents are going to be in one of the 2 largest classes. And these 2 classes have the negative and significant price parameters that we would expect, while the other 3 classes are very small and their price parameter was not significant. Further, all classes, even the smaller ones, have negative marginal utility estimates for the thinnest level of steak relative to the average level of steak. And this is shown in this figure here. So as you can see on the left-hand side of the graph, going left to right is going from the thinnest steaks to the largest steaks. So the biggest steak we considered was a 1.5 inch steak. And we considered a 1-inch steak to be our average. And so anything below average thickness decreased consumers' marginal utility. Whereas anything above average thickness either kept their margin utility about the same or increased it for Class 1. Getting into our willingness to pay estimates, there's quite a bit on this table here, but I just want to point out a few specific estimates. The ones that we're looking at are estimate for the thinnest thickness relative to the average thickness. So the thick steaks relative to the 1-inch thick steaks. And you'll see for both classes, this estimate is negative and significant. So this estimate suggests that consumers in Class 1, you would have to pay them $9.35 to accept a 1/2-inch steak relative to a steak. And the effect on Class 2 is even larger. You would have to pay consumers in this class over $20 to accept the thinnest cut steaks relative to the average cut steaks. This, along with the margin utility, puts together the fact that consumers just really don't like the thinnest cut steaks. And therefore, it may be an issue for restaurants and grocery stores who are trying to meet either target portion sizes or target package prices to adjust the weight of their steaks. Finally, we look at a welfare change. So in this case, we looked at a choice set of small thick steaks relative to large thin steaks. So small thick steaks would be the scenario from decades ago. And what we show for each of the two latent classes are a decrease in welfare by going from small thick steaks to large thin steaks. Now the first class was not significant at 5% level because the confidence interval just barely includes 0. However, it is significant for Class 2, and then also for just the base conditional logent model, we see a negative welfare that's statistically significant. And by using Classes 1 and 2 and their estimated welfare change per choice, multiplying that by the number of steak purchases in the U.S. every year, we get a welfare decrease of $8.6 billion by moving from a choice set with small thick steaks to large thin steaks. And so our key conclusion is that increases in carcass weights have not been great for steaks, and it's not been great for all cuts. And for some steaks, grocery stores and restaurants are already facing difficult choices on how to adjust the size of their steaks or to offer consumers heavier packages with larger steaks. Thank you, and good luck with your own lightning session presentation.